Thank you for the introduction. Yes, I work at Red Hat, and I'm in the team that manages and develops systemd. And I have also been a Python user for, I don't know, 15, 18 years, something like that. I want to talk about taking a Python service and using systemd to run it, and then at the end a bit about reversing things and using Python to control systemd. So the plan is that I want to talk about systemd and running services in general as an introduction, and then show a service. I asked my friend to write some Python code that is ready to be put on the internet, and then we'll check if this code is actually ready to be put on the internet, and we'll use some systemd settings to make it less terrible, and then some more settings, and then I want to talk about some new functionality in systemd that can be used to pass secrets to services, and then at the end, if the time permits, to talk about controlling systemd units from Python. So, right? I mean, since this is a Python conference, I think it's fair to ask why should we talk about systemd? And systemd is installed on almost all Linux systems now, and most computers run Linux. So, well, systemd is already there, and if you write something, you need to deploy it. And systemd is very good at running services, and it allows you to build like a defense in depth layers and layers of protections, which you probably want to add. So to do the other existing things. So you might have the service written as securely as possible on its own, but then it might be wrapped in systemd. Configuration that I will talk about later, and then you might have Linux on top of that, and then a firewall, and then probably some monitoring, and so on and so on. As you will see, systemd, one of the directions of systemd development is putting more emojis in code output. So this is the service. I put a URL in case, a QR code in case anyone wants to look it up locally. And is this okay? The sound? QR code also here. So this is the service. It has some headers, and it's living in Flask. So I'll skip the headers. So I want to go over this just for a second to show you. I mean, it's also a testament to how awesome Python is, that you can write a total of 70 lines of code and have a functional thing that does quite a few things. I created a Flask application. I wrote some wrapper to capture exceptions, which is not very interesting for now. Let's skip it. And then the actual functionality of the code is all that you see here. So the app provides a few entry points. I can connect to the application, and at the root I will get this help. And I can look at the getOS path and print some output. So instead of talking about this, let's run it. I have a terminal here. So this is my application. I'm told that it's very secure, so I'll just run it here. Flask. Let's run this thing. It gives some warnings, but it runs. And let's connect to this address. So this string here is it's not HTML, it's pure text, so it's displayed badly by the browser. So this is this text that you see here, right? And this string, and the idea is not to run it through the browser, but directly on the command line using curl. So I will use curl to address the same URL, and I get this text. So nice. So it works. And let's try the API endpoints. So GetOS gives me this nice dictionary that describes the system. And if you look at the implementation here, it's essentially one line. It's Python standard library platform module has native support for the OS release file. So all this information here comes from this file, which is a standard, maintained, proposed by systemd and used to describe the system. So I think it's very nice that this has been integrated in Python extended. And now returning to the index of function points. There is also an exit command. So, as you might suspect, this will be kind of a source of problems later. But let's run it as documented now. I can do date, and this just runs the date command internally and returns the date. And I can call the cal, and cal runs cal. I said that I want to run this as a systemd service, so let's do that, because right now it is just running as a command in my terminal. So how do I make this into a systemd service? So there's two basic ways. One way is to write a unit file and put it somewhere in one of the folders that systemd likes. So usually systemd system or etc systemd system and so on. Or a nicer way, especially for development, is to use systemd run. So systemd run takes a set of unit settings on the command line, sends a dbus message to the system manager, and the system manager takes this dbus message, creates a unit file from that, and starts it as a service. So, or another unit. So it's all the same as running a service from a file, except that it's done dynamically from the command line. And the advantage is that if we write a file and we make changes to the file, we have to reload systemd settings with daemon reload, then restart the service, and then when we do it 15 times in a row, we forget one of the steps, and then we make changes, and those changes are not active. This is annoying. And with systemd run, we avoid this, so it's nicer for development. So, so let's do that. So systemd run. This should be enough. And it asks for a password because, I'm starting a system service. I will press escape here, and I will just run this through sudo, because this way it won't ask for the password again. We get a service. We can check the status of this service. It shows a bit of logs. We can look at all the logs. But this is also a bit annoying, because if we want to do interactive work, we would have to repeat those commands over and over. So instead, I will stop this, and I will repeat the run command with -t, which means that the terminal, it connects the output of the unit to my terminal, and also connects the terminal as input to the service. And this way, I can see the output here, and this is nicer for development. And I want to underline the fact that sudo works this way, that all the options until the first non-option word on the command line are options for sudo, and then you have the command line. And systemd run works the same way, like all the all options that are before the first non-option word, which is flask in this case. I should increase the size a bit. Are options for systemd run, and then we have the command with some options. So this is the actual command. And it's running, and we see the output, and it should. Sorry for this. It should work. Still works. And now, if we look at the implementation of command here, it does some checks, right? I mean, those checks are they work. And we can verify this. So I will execute ls, and ls works, and it passes this check here. And what it does, instead of throwing an exception, it prints an error. I think that there was some Java developer here, and this is the message we see it here in the terminal. It's just a string that is printed. This allows us to execute arbitrary stuff as the service, which is probably not good. So let's check who is running the service, right? And I started via sudo, so it's a normal system service, and it's running as root. That's the default. So we have remote code execution as root. Well, not remote because it's listening on localhost, but otherwise, yes. I was also told that we get public DHCP addresses here, so that's. Okay, so we have this. Right. So I'm running as root, and it would be really good not to run as root. So I will stop the service, and systemd makes this is very easy. So we say user equals something, and we give a username. So for example, just to test, I'll run this as myself. And I put this thing in the wrong place. That's what I was talking about. And now, if I test this again, I'm myself, which is maybe slightly better, but still not ideal. So one option would be to call add user, create a user, create a group, and then a user, and make sure that the name is right and something like that. But this is a lot of work. We don't want to do a lot of work. We want to do something easier, and this is call dynamic user equals yes. So the yes is not a name; it's just a boolean. Maybe one is also the same. And now the service is running, and if we look at the output from this, and the output here, so this is the name of the service. So this was the name of the service, and this is the name of the user, so they match, right? And actually, if I check this user, it has a number, it has a group, and it seemingly exists. I mean, like if I call PS, it will show that the process is running at this user, but it's not saved in etc passwd. The user is provided dynamically on the fly whenever you query for the list of system users. So check this service. It's there, it's running, and this process is running under this user. this. The name is abbreviated, but it's there. And if I stop the service and I query for this user, so the service is not running, and the user is also gone. So the idea is that we have various resources, and the resources are tied to the lifetime of the service. In particular, the user and the group, and some other stuff later. And well, I will be talking about other things later, but actually, if you are running the service as an privileged user, you're already like 60% of the way from being a root-owned service running without any restrictions to being a tightly locked-down service, or maybe even more. Because the user, well, cannot write files to the system, and it's severely limited in what it can do already just by this one setting. But well, it can still access files. So I will execute ls, and I want to see, for example, what is in home. If I call this will not work, but I can escape this here, and then this works. So just to show that it actually allows executing everything without any complicated steps. And if I want to add -l here, you can see that, for example, the service still has access to all of the file system. So this is, it probably cannot modify things, but maybe it can read things and read stuff in PC and so on, and this is not good. So let's make this not possible. And there is a system that has a bunch of settings to make this easy. So generally the idea is that you have high-level settings that like do a fairly high-level concept. In this case, for example, hiding /home. And then many low-level settings like make a specific path inaccessible, which then you have to combine in specific ways. So when you use the high-level setting, you don't have absolute control over every detail, but it does the idea is that it would do the generally right thing. So protect home equals yes. I run this again. And if I call this, I get an error. So it's a called process error because we're using subprocess to execute this command. And if I look here, this is the output from ls itself, and well, it cannot open home. Permission denied. And if we look, if I look at the home directory, well, it's publicly readable, and if I execute this same command here for the service, you see that it has been, well, the permission have been changed. And the way that this happens is that the systemd manager creates a mount namespace for the service, and in this mount namespace it does, well, manipulates paths, hides some file systems, adds new ones, and in this particular case it simply overmounts an inaccessible directory where /home, so that even if in general the service just does not see it at all. So there's a few of those protect something settings. I don't want to go over them, but there are just one more: protect home and protect system. Yes. So protect home is kind of simple because it just hides stuff, but protect system is slightly more complicated, because what it does is it makes things still available but read-only. So So if I do this touch, and I try to create a file in the root directory, this does not work, permission denied. If I do the same thing, via the service, well, I also get an error, but the error is actually read-only file system, not permission denied. So the idea is that even if access permissions on the file system would allow modification, the file system is mounted read-only, and the system cannot, the service cannot modify the files. And I see the questions, so let me answer them. How does the temporary user read the source of the Flask app? So, yes, I cheated a bit here. I put the Flask app in some Python, in the Python package search path, so that it's actually available to all users. So basically it just loads it from Python path. Would it be simpler to deny all and then give specific permissions to process user? In theory, so I'll return to this question later, because it's I think it will be easier to answer at the end. Is there a way to dump settings from systemd to a service file? Yes, I plan to show this later on. It's a normal file that you can just copy. User dynamic user. Okay. So the service is running, and now let me load up the index again, and I want to test the functionality of getting and writing files. So, well, we mounted most of the file system read-only, and now that's kind of annoying, because if you want to save a file, then this will not work. So we need to make this possible. So what I want to do is I want to make a post request to this files file1 address, and data ASCII equals test. So before I do this, let me stop my service and go back a few steps, and I remove the protect system. Just let's run it this root again, and I do this. Okay, wrote 9 bytes. So where did this file go, right? If we look at the code here, it creates a local files. I mean, it operates relative to the directory from where the service is running. And well, what we can do is we can exec path to working directory and just see what the path is on its slash root. So if we actually look here, well, we have a files directory, and the file that I just created is there, and since it's running as root, it's owned by root. I mean, root can do anything. This is probably not ideal. Just move this. And so I want to go back to this point, and I want to, well, I want to create a place where the service can store files, and tell it what to store files there. So, what? Ah, thank you. So state directory, and it wants a name. I will call it like the application. So we have a state directory, and it's running as a dynamic user, and what I want to do now is I want to call env. So I'm calling env, and env will print the environment block the service, and it's actually fairly small. So what systemd does when it is starting services, it will, I mean, if I do env in my, well, here, it's rather longer, right? And systemd will sanitize, will start a service with an empty environment and insert specific variables, and which variables are inserted and with what values is documented in the systemd event pages. So we have like the lang path setting so that things work, and the username. We have term. Term is set because of the -t option, because the output from the service is connected to our terminal, so if it wants to write to the terminal with correct codes, it needs to know what the terminal type is. Normally, it wouldn't be set. This stuff comes from Flask itself, but the setting that I wanted to show is this one. So systemd starts the service, and it needs to tell the service that the configuration specifies for example, a state directory. One option would be to configure this again via some option in the service itself, but we don't want to do this. We want to make things, well, I mean, not require specifying things in two places. So it passes an environment variable. And then the idea would be that the service would look for the state directory variable and just create any file that it needs to create underneath that, whatever that variable contains. So let's look at this directory. I'm running this on the host, so not as the service, but as a normal user. And this it's a symlink, and it's marked in red because I'm not allowed to read the contents. If I look at private and the directory itself, the permissions for non-owner of this directory is nothing, and that's why I cannot list this directory. But let's do the same thing from within the service. ls space -ld space /var lib private, and we see different permissions. And again, systemd is manipulating the mount namespaces of the service so that it can actually access this directory. And as the service, we can look into this. If I remove the D, it's just an empty directory. Oh, there's some stuff from I was testing this before, and I can also access it via the symlink, so this just works. So we have this state directory. We can access it as a service, but it's protected from anyone else running on the system. We got this private thingy. So I mean, root can access it, but not unprivileged users. And now we want this. Let me remove this because this. So I will stop the service and remove the whole directory again. So it's not there. Start the service again. So this is dynamic, right? I mean, the directory doesn't exist; it's created on the fly. And as running as root, I can list it. It's there, now it's empty. So let me do the post. I'm trying to write the file now, and well, it fails because the service doesn't know anything about this state directory variable, and it's trying to write to /root, not / files again. And this hopefully does not work. I mean, it's good that it doesn't work. We need to tell it to write in the right place. But let's say that we cannot modify the service. So what we will do instead is we'll tell systemd to start the service in a different place. And this just will be just valid. And hopefully, yes, I can create files. I can retrieve the file now. If I call this correctly, I can retrieve the file. And if I look here again, well, the file is there. So, right, I mean, systemd takes on itself the management of of a storage directory and changing files so that other users cannot access the contents, and it also creates the user and so on. So this all becomes quite simple then compared to if we wanted to implement this in the service. Okay, so now returning to the question from before, could we make start with a very locked down service and then add specific permissions? So there's like two answers to this. The first one is historical, that traditionally, I mean, systemd was written to start system services, and traditionally they would start as root with full privileges and no limitations whatsoever. And for compatibility, it was easiest to do things this way. But also, many of those settings, like, I don't know, protect system, didn't exist when systemd was introduced. So if we were restarting with the process now, we would probably start with a large set of settings enabled by default, and then ask people to disable the ones that they don't need. But retroactively adding limitations to already existing services, this would break services, right? Because it's really hard to figure out what specific service, what permissions it needs, and so on, unless you know the service very well. So the only option is to ask people to add those settings if we don't break backwards compatibility. And of course, we don't want to do that. And also, the problem is that later on I want to talk about more specific filters. Those specific filters are generally so specific that you cannot even start a program. So most programs, if we enabled many settings, most programs wouldn't run at all. So this wouldn't be useful. So I mean, it's really hard to say, let's lock down things maximally and then open. So, can you change file system root to specific directory for the service using systemd? So, let's consider the case of this Flask application. To run, it needs Python, it needs the Flask file, it needs some modules, it needs the cal binary and the data binary, and so on. So if we were to run it in a change root, we would need to copy all those files into the change root, right? And I mean, this is certainly an option, but it's like a more traditional approach. I think that it's just nicer to run it with a view of the real system, especially like for something complex that interacts with the system, more complex in this application, and then just limit what it can see, because it turns out that we can quite easily limit what it can see. And can different services access each other's files? Yes, to some extent they need to. I mean, this particular service doesn't need to and shouldn't need to access anything else. But sometimes we have a situation where, for example, I don't know, the service needs to talk to the keypass daemon or whatever, or the database, and then we want to allow some communication between services. But in general, by default, we want to make things so that services cannot access each other's files. Okay, so I want to show one, I think, pretty cool thing. So this service, stop it, it's running. It still can exec anything. So for example, it can exec ls. Let's make it impossible for it to exec anything except date and date and column. So the setting for this is called exec apps, and we just list what it should execute. So date, bin cal, bin flask, and no exec apps is so it's like an allow list, deny list setting. So deny everything, allow those three. If I try this, it doesn't work. If I look at the logs, it doesn't say much. Permission denied. It cannot execute Flask. This is because Flask is a Python application, right? So actually, to execute it properly, it needs Python. It is, but it follows similarly, so it doesn't matter. So it needs Python 3, and it actually needs libraries also. Now if I allow Python and a bunch of stuff with user lib, then this works. If we call ls, this doesn't work. If we call date and cal, this works. I think this is kind of can be pretty nice for stuff that should execute some things but not other things. There is like a million of those, well, not million, but a couple hundred of those settings, and I should stop here. I want to mention private temp. Private temp uses mount namespaces to hide or to provide a private /temp and /var temp directories to a service, so it protects the files of the service, temporary files of the service, from the outside and vice versa. And for network services, there is a very interesting option called private networking. So with private networking set to yes, the service runs in a private network namespace where it only has the loopback device. So it cannot open any connections. And this is the ideal way to run network services. Well, because they cannot do things. And well, you might ask, what about the connections from the outside? And the idea is that you inject the socket that the service should listen on from the outside via socket application. And there's a system called filter setting that allows you to filter individual system calls if you really want to do like a very, very tight lockdown and so on. So there is a systemd exec man page that has lots of contents, and I promised emojis, so let me show some emojis. So one way is to look at the documentation and figure out what you need. The other one is to run systemd analyze security. So I take the service name here and I call systemd analyze security spend. Doesn't fit. So it has like a list of settings, and for example, if I go to the very end, it says that the boomask setting is not set. So this is something that I might legitimately want to set for this service. It has some explanation, and it calculates some scores, and in the end it says, well, gives us a total score. The 8.1 is on a scale between 0 and 10, where 10 is the worst. So it doesn't like the service. I mean, it's like it's a hint, right? It's not and it does like smiley faces or frowning faces. So I think the idea is that you run this and you look at the things that it suggests and maybe enable some. So I want to show this thing because this is new functionality that's really, it was really added in the last systemd release that was made like a week ago. So it's systemd creds. Instead of explaining, I will show how it works, and I think then it will be fairly obvious what is happening. So systemd creds encrypt. It takes an input file and an output file. So my input file is dash because I want to provide the input on standard input. So I will say secret. So we have a secret and we encrypt it. This fails because we need root permissions for this, which will be obvious in a moment why. Because, well, it uses the TPM to connect, to encrypt the data. So, what does this mean? If we look at this file, it's encrypted, and it's encrypted with two keys. I mean, you need both keys to decrypt it. There is a in varlib systemd. There's a secret file with some encryption key that systemd uses. So if you were to take this password bin file and move it to a different machine without this one, you wouldn't be able to decrypt it. But this is most likely like a additional thing. The main protection comes from the fact that those contents here are encrypted via the TPM. So if you take the disk out of my laptop, and if you get all the files, you still wouldn't be able to decrypt this because you need the TPM, which is, well, either part of the CPU or route to the motherboard. And, well, we can decrypt this. So, credentials decrypt. If I decrypt this, it takes a moment, but it just gives us the file back. So the idea is that you would use this for passwords, for TLS certificates, for some special configuration that shouldn't be available publicly, and so on. And we can pass it to the service. I know I'm reaching the end of time, but let me do this quickly. So I will remove the no exec paths because I want to run env again. So load credential encrypted equals, and it will be password bin, and I mean, there's a few options here, but one is to just give an absolute path. So from this directory and the file. So you can see that I'm giving the password bin name twice, And this is because systemd insists that the credential name, so this is this part here, that the service is actually the one that was used when encrypting it. So that you cannot confuse a service by taking one encrypted credential and substituting it for a different encrypted credential with a different name. Okay, so this is running, and I wanted to run env. And so before we had the state directory, and now we also have a credentials directory. And if I do this, this, we have a file that is owned by the user running the service, and if I actually show the contents of this file, it's the decrypted secret. And the idea is as before. We have some resource, and when the service is started, the resource is decrypted and made available to the service, and it's also protected by, it's stored in systemd will make some effort so that it's actually never written, for example, to a swap file. And then when the service is stopped, it is destroyed, and the lifetime of the decrypted credential is bound to the lifetime of the service. Okay, and right, to wrap things up, there was a question how to access the unit file, right? So if I take this service, copy the name again. It's a normal service. It's in /run. So when the machine is reserved, of course, it goes away. But it's a normal unit file, and we can take this unit file and do whatever we want with it, right? Use it as a basis for a normal unit file, probably. And generally, all these settings are here. We want to get rid of those ones which are specific to being connected to our terminal. And more questions?
I'm afraid there's no time for questions.
No time for questions. So one sentence. So right now the Python service was under systemd, but we can also control systemd from Python, and there is a pystemd module, and in particular it allows creating objects that wrap systemd units as objects and interacting with units, starting them, introspecting settings, creating units via dictionaries of settings, and so on. Which can be interesting if you want to start systemd units programmatically. And that's all I have. Thank you.